Okay, next example, 6, we have to integrate this. But in this case, they ask you to reverse the order. And after you reverse the order, then you solve for the integration. In this case, if you if you directly integrate using the given order of integration, you will not get mark because you're not following the instruction. And in fact, your calculation is actually becomes, if you are directly integrate first with respect to y, it is quite complicated for you to integrate easily. I mean, I'm talking, it can be solved, but a bit harder. Rather than you reverse the order, which is you integrate with respect to x first, and then your expression becomes more simpler. Then you can directly integrate then with respect to y, and you will get the answer easier. Okay, but then the problem here, they don't give you the information about the region, because you need the information of the region so that you can determine the new limit of x and the new limit of y. Okay, when we said that we want to change the order or reverse the order, you actually cannot. Okay, you cannot. Okay, we don't change the integrand, but we change the order. And I mean here, you cannot just swap the location of the limit for like that and then 0. Why we cannot do like that? This is mathematically incorrect. That is because of, you can see that your outer function there is in terms of x, so which means that when you solve that, your final solution is in terms of x, which means that as we know, the definite integral, which means that if your integration there is limits, then your answer should be a number. So if you have like this, so your final solution is not a number, so this is mathematically incorrect. So then we cannot do like that. So now when you change the order, so you don't change the integrand, so now dx dy, so you have to obtain the new limit of x and the new limit of y. So how can you obtain the new limit of them? So you need the region. So then how can you know the region? Because of there is no extra information provided and saying or telling about the region. So actually, you can get the information from the limit provided. Okay, because you can see here, actually you are given a complete set of double integral. But since it is quite complicated to be integrated directly, so there is a need for us to change the order first. Okay, so how can we obtain the region? So now you can get it from the limits provided. So now your limit of x, which is given, is 0 to 1, and then y, x to 1. So then from here, you can write down some equation, which means that you have x equal to 1. From here, you can x equal to 1, x equal to 0, and then you have y equal to 1, and you have y equal to x. So you got 4 equations where we'll give you 4 curves or 4 lines. So now from this, you can sketch the graph. Okay, so among of these 4, the equation that we have is y equal to x. So I will start with the equation first, where we have a linear equation y equal to x. So this is y equal to x on y-x plane. Okay, and then the rest will follow through, which means that I have x equal to 0, I have x equal to 0, and I have x equal to 1, and I have y equal to x, and I have y equal to 1. So where is y equal to 1? So now, since we know this one is 1, so now we know this one should be equal to 1. So when y equal to 1, so that is the line. Okay, so now I'm sure that now you get stuck because you're not sure where is your region that you need to shift, isn't it? Okay, so now to help you in getting the right or the correct region, so you need to go back to your given order. So now you have dy, you have which one? Okay, you have dy dx. So the given order is dy dx, which means that x constant. So as we know that when you have x constant, what is the line that can help you to determine the limit? Remember I told you before, if x constant, you have a vertical. If you have y constant, we have a horizontal. So in this case, x constant, so we have the vertical line. Okay, so now you can see that. So based on your interval, your given interval, now you want to read where is actually from this the given limit. You can read from there, and then that will tell you where is the region that you have to shade. Okay, so now we can see that the orange line here is lying between 0 to 1. Okay, and then now look at y. So look at y, the lower bound x. So where is the line of y equal to x? So as you can see from this line, so your initial point is along the y equal to x line, and your terminal point is at y equal to 1. So where is y equal to 1? So y equal to 1 is here. Okay, so based on your initial point and your terminal point, so we know that the region that we need to shade is lying here, lying inside there, and that is your region. Okay, so now we already obtained the region. So now back to our intention, we want to change the order. Well, now we have y constant. So now we want to work on dx dy. So y constant. So when y constant, now you should draw horizontal line. Okay, so then from the horizontal line, you can determine the limit of y. So you can see that the line here is lying between 0 to 1, right? And then x. So look at the purple line, So now you are walking along the line through this direction, from the left to the right along the x-axis. So when you read from the left, so you just walk slowly, and what is the first point that you can see? So the first point that you can see is this point. So that point and the terminal point should be over here. Okay, so how can we know that? How can we know the limit of x? So the initial point is lying on what is the equation of this? X equal to 0, and then this is the terminal. So this point belongs to. Now you have x equal to, not y equal to. So we know that the original equation given by y equal to x, but now you read as x equal to, so x equal to y. So now your new limit y is 0 to 1. Okay, and then x 0 to y, 0 to y. So next we want to solve the integration. So we solve for the inner integral where y is because of we want to integrate with respect to x, so y squared here is constant. So y squared is constant. So we just focus on the e xy dx dy and x from 0 to 1. So we just work for this first. Okay, so now because of you have e in terms of xy, so in this case you need so it looks like we have a function in a function, right? If it is differentiation, you have a chain rule. But if you can see that some layer of equation, there is a function in a function. For integration, you have to use the substitution. Okay, so now we want to solve that using substitution method. So now we let I'm using u equal to xy. So next what we are going to do is we want to have the expression of dx. So how can you obtain the dx from u equal to xy? So you have to differentiate du over the x, so that you can use the term of the x over here. So when you differentiate with respect to x, so you have y. So now your dx is du over y. And then when you replace back into your integration, so e xy, so now what is actually the idea of the substitution? So we want to simplify the form. So we want to simplify the form by assuming the new form after that is in terms of only u. Okay, so now that's why we need to replace the e in terms of u. So as we know, as we assuming just now, xy is u, so we have eu, and then replace the dx, so your dx is du over y, okay, and dy. So we don't start the integration yet. We just started by transforming the xy term into u. Okay, so now what we can have, so you can have they are all multiplication, right? So now we can simplify. You have y squared and you have y. So it looks like we can have y, only y, and then you have eu du dy. So now there is no more x. So since there is no more x, just in terms of u and y, so we can proceed the integration. So now we can see that our expression becomes more simpler. So that's why they ask you to reverse the order. Because if you just proceed with the integration with respect to y first, so your calculation becomes messy and becomes harder. Okay, so next we solve for the integration of eu. So you will get the eu back, and then substitute the limit. Okay, so the limit. Okay, so the limit is for x 0 to y, and then because of the limit is belongs to x, and this one is just u, so you have to replace back what is u in terms of x. So we know that u is equal to xy. Okay, and then we substitute the x from 0 to y. So now you have to be careful, the substitution only for the x. So now you just replace, so you have y, okay, x is y, so you have y squared minus e0. So e0 is 1. So now you have y squared minus 1. So now, next you have the, there is a function in function as well, but you can see that this one, y squared, the exponential of y squared, and you have y here. It looks like you can use the substitution because we want to simplify the form. Okay, of course you cannot use the by parts because this is not there is no the multiplication of the sign and the polynomial. It just two expression. You can see that there is y squared here inside here, and there is y outside here. So by using substitution, so you can simplify the form. So which means that now I'm using u. So let u equal to y squared. Okay, so maybe I have to split that first. So y squared minus y dy. So for minus y, you can easily integrate where it will give you y squared over 2, right? But this one, you have to use a substitution. So let u equal to y squared. So you can replace this, become eu. So now you have du over dy. So you have 2y. So now your dy is du over 2y. Okay, it looks like if I solve this one by one by one, y. So this one's supposed to be dy and y dy. Okay, it should be negative. Okay, so now For the first term, I'm using the substitution where now I have y eu. So dy is du over 2y. And this one, I will get the answer straight away, isn't it? Okay. So now the y here can be cancelled out. So we only have the integration of half of eu du minus y squared over 2. So now everything here for the first term, we already simplified the form only in terms of u normal y. So now we can proceed to do the integration. So you have eu minus y squared over 2. Okay, so your y is from 0 to 1. So you can put the 1 over 2 outside because that one is a constant. So you only have e. So what is your u just now? Y squared. Y squared minus y squared. Okay. So, and then we replace 0 to 1. So 1 over 2 e1 minus 1 minus e0 minus 0. So I have this one is 1. So e minus negative 2. So I will get, or you can write down to be 1 over 2e minus 1. So that is the answer. Maybe you have a more simpler way, so you can use your own version. Okay, as long as it is mathematically make sense. Okay, you follow the rule of the substitution and so on.